Lesson 4 we're going to look at is on the constant of proportionality, or looking at proportional relationships. So if we look at this on page 104, example 1, a sponge is an example of a filter feeder. It takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. What is an equation that represents the proportional relationship between the time and the amount of water filtered? Okay, so they're telling us it's proportional. The question is, they want us to write an equation. So we're going to be learning about this, how we can write an equation. So what's happening here is 8 liters in 10 hours of water for the sponge, 12 liters in 15 hours for the sponge. So what we're going to have to do here, first of all, to come up with an equation, we're going to have to figure out a constant of proportionality. So constant of proportionality, the book says it's a constant multiple that relates the proportional quantities x and y, and it's the value of the ratio y over x, and it's represented by k. So that's a lot of underlined stuff there, or you can circle that whole deal. Okay, that constant of proportionality is what we're going to be looking at. So a question I get a lot whenever we talk about this constant of proportionality is, okay, it's a constant of proportionality and we're using the letter K. Why don't we use the letter C, since constant starts with a C? I think it has to do with the fact of other languages having different words than what we do. So, for example, I took German in high school. So, in German, the word constant is Konstant, and so it's with a K. And so I can't remember for sure if that's the exact, place that originated at or not. But anyway, something to do with that, I think, is why we're using a K and not a C. Okay, because we have other countries, and math is a universal thing, so they kind of do the same thing in other countries with this. So what we're going to do, first of all, we can make a table and figure out our constant of proportionality. So constant of proportionality, basically, if we think about this, constant of proportionality, in a lot of cases, really in every case, it's going to be basically like a unit rate that we've found before. Okay, so we're just going to divide the y by the x. So the liters is the y, the hours is the x. This is going to find how many liters per hour that the sponge is filtering. So 8 liters in 10 hours, so 8/10. You could put that as a decimal, would be 8/10. You could just reduce the fraction, otherwise would be 4/5, would be okay also. Normally, we're going to lean towards fractions. This is a case where if the decimals are nice, it's probably not too bad just to go with the decimal, especially if we have a calculator to work some things out we'll talk about later. The other one, y over x, we got 12 over 15. If you divide, you get 8/10, or again, that would reduce to 4/5 if you reduce your fraction. And they told us it was proportional, so we could probably really just look at one or the other of those. We probably wouldn't necessarily have to look at both of those, and we would know that that's our constant of proportionality. Okay? So what are we going to do with that? Well, we're going to use some information here. So we said K is equal to y over x. What we're going to do is we're going to just rearrange things a little bit. So K equals y over x. We're going to solve the equation for y. If you guys have ever seen some of the older kids, or maybe older siblings, have those big graphing calculators, okay? Those graphing calculators, you can actually graph equations on those if you type it in as y equals something. So that's going to be kind of a thing as you go through math. When we have equations with y and x, we're going to try and figure out y equals something, and then that way we can maybe, if we're allowed to use the calculators, we can graph it, or even if we're not allowed to, we can just work it out by hand pretty easily. So you might look at that, k equals y over x, and you want me to solve that for y. And some of you guys are probably thinking this is pretty crazy. But what we're going to do is, if you just think about, instead of the k and the x, if we just put some other numbers there, if we have numbers there, this is like something we've done before. So like we've done before with solving equations for variables, we're going to do the opposite operation. The y is being divided by 5. We're going to multiply by 5. Okay? Now, you might look at that and you might say, well, yeah, on that problem, sure. But over here, I don't have a 3 and a 5. I've got a k and an x. Well, it's the same deal. They're dividing by x. We can multiply by x. Okay? And then the next line here, the book has kx equals y. Commutative property, remember, for multiplying, we can switch the order around, right? So instead of x times k, that's the same as k times x. And then basically now we're just saying if these two things are equal, if we flip-flop them, they're still going to be equal, right? If kx equals y, y equals kx. Kind of like if you've ever seen a balance scale, a double balance scale. Okay, these things are equal. If we switch what's on the sides that was equal, they're still going to be equal. So this is what we're going to be working with for our equation in this lesson. Y equals kx is the equation that represents any proportional relationship. Okay, so that's going to be the equation that we're going to be using. And then, like I said earlier, from that first part, we've got k is equal to y over x. That's going to be the other thing we're going to be looking at. So, using that equation then, we'll just substitute in, since we said k was equal to 8/10 or 4/5, we just substitute that in place of k in the equation. So either y equals 8/10 x or y equals 4/5 x. A value of having that equation would be if we're trying to figure out for a lot of different things. Okay, if we're trying to figure out what y is, in other words, in this case, we're trying to figure out how many liters of water for a bunch of number of hours. So like if somebody said, well, how much water would it be for 20 hours? How much water would it be for 24 hours? How much water would it be for 50 hours? If they kept asking all these different questions, if I have this equation, all I have to do is multiply 8/10 times how many hours, and that would find my answer for me. Okay? And again, it does kind of go back to that unit rate idea. You know, some of you guys, we could probably work through and figure this out without technically having an equation, but if they say write an equation, we have to write an equation. So if we look at the try it, Maria made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities. Okay, so they said apple juice is X, grape juice is Y. And the main reason why we would probably do that is going to be if they would give me a lot of apple juice numbers and say how much grape juice would we have for that much apple juice. Okay, Y is going to be what we're trying to find values for usually. So for the first numbers that they've given me, if we look at y over x, now be careful, y over x in this case would be 8 over 5. For the second one, it's going to be 16 over 10, which we could reduce to 8 over 5. Now, if the decimal comes out nice, again, we can use that. It's probably not a bad choice either in these situations. So if you divide 8 by 5, you'll get 1 6/10. Okay? Notice those both come out the same, so we know it's proportional. So what that tells us is our punch is going to taste the same pretty much, right? We have the same proportion of apple juice to grape juice, or grape juice to apple juice. So our constant of proportionality, remember that's constant of proportionality is K, okay? And it's that y over x value that we found. We just did it. It's 1 6/10, or you could say 8/5 if you wanted, whichever way you want to put that. That's your constant of proportionality. So our equation then, remember our equation, we're doing y equals kx. And all I'm going to do in place of the k, I'm going to put my constant of proportionality. So my equation would be y equals 1.6x or y equals 8/5 x. Either of those would be fine. Again, probably not too bad with the y equals 1.6x if we're substituting a lot of numbers. Basically, that y over x, that was our unit rate. We said there's 1.6 quarts of grape juice for every 1 quart of apple juice. Okay? And so then with our equation, we're saying, all right, let's take our quarts of apple juice multiplied by 1.6, and that'll give us how many quarts of grape juice we have. So again, it might seem a little weird, some of the stuff we're doing, like what's going on here, but it kind of, if you think about how it's working with things that we've done before, hopefully makes a little bit of sense here. Example 2, 1 inch equals 2.54 centimeters. How many centimeters long is an 18-inch ruler? If this was the only thing they asked me to do, I would set up a proportion and I would be done with this problem in not very much time. Okay, 1 inch is 2.54 centimeters, 18 inches is what? And we could just say multiply by 18, and we work that out and we get our answer, and we're done. Okay, as it is, we're going to assume that they want us to write an equation and work it out here. All right, so as I mentioned earlier, when you guys are setting this up, if you're going to make an equation, it's best to make y what you're trying to find. So in this case, we're trying to find how many centimeters. So let's make centimeters be the y. In other words, let's make inches be the x. Okay? So what we could do, kind of scratching that idea of what I was showing you earlier, because we're going to assume we're just going to go along with finding an equation and stuff. So the first thing we've been doing is finding our constant of proportionality, which is found by y divided by x. So in this case, y we said is going to be the centimeters, and x is going to be the inches. So if you notice that over here, so that would be 2.54 over 1. 2.54 centimeters for 1 inch, okay, which is like our unit rate. Well, 2.54 divided by 1 is 2.54. And then from there, we can come up with our equation. So we've got our equation. For our equation, we do y equals kx. So if k is 2.54, we're just going to substitute that in. And then we've got y equals 2.54x would be our equation. Okay? So if they were going to give me a lot of inches and figure out how many centimeters it is, this is what I would want to do. With one, like we're doing here, I probably wouldn't go through all this trouble, but that's okay. So then we can substitute, take your equation, substitute an 18 in for x, because that's 18 inches, and inches is our x value, and then you just multiply those out and you get 45.72 centimeters. So if we look at the try it, this is not typically the situation, but we have a florist sells a dozen roses for $35.40. Sells individual roses for the same unit cost. Okay, normally if you've ever heard the phrase cheaper by the dozen, okay, normally if you buy something by a dozen, it's cheaper than buying 12 things individually. Write an equation to represent the relationship between the number of roses x, so number of roses x, and total cost of the roses y, and then how much would 18 roses cost. They told us what to do here. They didn't have to do that, but they did, so that's okay. So x is going to be our roses, and the cost is going to be the y, costs in dollars. So we had 12 roses is $35.40. So we know to find our constant of proportionality, we're going to take y divided by x. Again, it's just like our unit rate. $35.40 divided by 12, that's going to tell me a cost for one rose. How much does it cost for one rose? All right. So if you divide that out, you'll get $2.95. In other words, it's $2.95 per rose. Okay, but again, all we really need necessarily is the $2.95 part here. And then our equation, y equals kx. The $2.95 we can put in place of the k. That would be our equation, first of all. And then the second thing is, how much would 18 roses cost? So to figure that out, we would just multiply 295 times 18. Again, we could do this without the equation probably, but that's what they asked us to do, so we'll follow their directions. Again, it's 295 a rose times 18 roses. Kind of makes sense what we're doing here. And if you work that out, should be $53.10 for 18 roses then.